Hello everyone. The last time I made a video on Spring AI, the version which was out was 0.080. Um, since then they have released a few 100 milestones and I've made quite some changes to their uh, data models and everything else. But what I was interested in doing was running an LLM locally. So I mean, last time when I did this, I actually used my uh, ChatGPT key, and then we made a connection to the OpenAI endpoint and made it work like that using the OpenAI chat client, right? But this time I wanted to run something locally and and go from there. So I did some reading, and turns out they have added Spring AI has added support for Ollama chat. So before we go there, we can see how many chat models they support now. The list has increased clearly, and the one that I'm interested in is Ollama. So Ollama is a, I guess the wrapper. Think of it as a wrapper on few models, which it can help you run locally. So if we look at the models that it has support for, it has Meta's Llama 3 dot 1 3.2, which just got released a few weeks back. Then it has Google's Gemma, which is the open source version of the Google model, and so on. So basically, any open source model that it can find and support, it adds. So if you go through the setup for Windows, you just need to download and install it, which I've already done, and that will set up Ollama local um, on your local command prompt. So right now I don't have any models. I will pull one using this command, which is Ollama pull and then the model name that I want. So I am going for Llama 3.0, 3.2. If you open the page, it will actually tell you what's the size for the different models and like what some differences. So the 3.2 default one is 3 billion parameters, outperforms Gemma 5, and then there's some benchmarking here as well. So let me pull this. It should be a 2 GB model, yeah. So let it happen in the background while I'll run you some of the other things that we'll check. So yeah, we'll run this locally. Then the next thing which I wanted to do was explore how I can bring my own data to the model. So this section here talks about it. There are two ways that they mention. One is something called actually, like, there are three ways that you can do this. There's something called prompt stuffing. So basically, you just give the data that you want to the model at each prompt. So, like, let's say that I want to ask some questions about um, I don't know, where I was born and what's my birth date and all that stuff. So for that, I will give that context to the model, and while that context stays in the context window, it should be able to answer those questions. So a more advanced or a more better way of doing this is doing something called a retrieval augmented generation setup technique. So what this means is that uh, you are giving it all the context that it needs while um, like before you start asking questions. So we give the data source, and then it splits it into small chunks, and then it stores it in a vector store. Okay, so this happens before we start talking to the model. Then the when the query comes in, it tries to retrieve stuff from the vector store, uh, uh, adds our query to it, and then basically does the response. So by this way, you're still like stuffing the prompt, but you're doing it in a more refined manner, and you can save yourself like passing the same information over and over again, and so on. And then they have also added support for function calling, where you can call functions to like enrich the model, and I did not look into this time. So let's see if our bill came up. It did. So like Ollama makes it very easy. Like if I just do Ollama run and then the model which I just downloaded, it should just give you a chat client um, to talk to immediately. Um, what's your favorite? Okay, so you get it. So it will start answering immediately and so on. Okay, so um, in terms of vector database, where it will break the document and chunk it, there are Spring brings you these many options. Like if you want to use an actual database, you can use Azure, you can use OpenSearch, you can use SAP HANA, and so on. But for my thing, I would just do it in a very simple manner locally, so that we can look at it and we don't have to worry about talking to other things. And then finally, we will use something called Spring Advisor, which also they've recently added support for. And this basically will help us in uh, basically these are like pre-built advisors which can handle common patterns which we will implement. So like we are implementing a RAG pattern, and the question answer advisor is supposed to do a lot of bootstrapping for to improve the model's ability to do question answers. So let's do this, and we'll see how it works out. We'll start with a new project, and we'll see how this goes. Okay, so let's call it Ollama RAG, and let's do Maven. Let's set the language level at 21. Really matters. Then let's add our dependencies. We will need Spring Web. We will need Ollama Spring AI Starter, and that should be it. If we need something else, we will figure it out. Let's load the project. The structure looks good. First things first, we will need to provide some properties. So chat model has to be llama 3.2. Then we'll also do something with the embedding model, because like we'll have to do embedding in what we're doing, because the RAG infrastructure um, actually uses the embedding model. So we will also set that up. This should hope do it. And yeah, I think these two properties should help it point to my local Ollama installation. The first thing we would want to do is probably create a control. Uh, so let's do as controller, and then get mapping. Can that's okay for that's we'll have to do like some of the other stuff which will config file uh, where we'll implement our database. But before we go there, we will need some data to like load into the model, right? For that, I thought we could go and ask ChatGPT to spin up a funny FAQ document. So let's ask it to create a well-structured FAQ document about Olympics in 2048. Um, these games be the first to held in Mars. Okay, so basically the idea here is that I'm trying to give it some data which is local to me or personal to me, and so on. So, like a common use case could be that you know uh, we have FAQ documents in our offices which are not public, and then we can probably throw them into a model and create a chatbot to uh, you know, fetch stuff from there. So that's the whole idea with feeding a FAQ here, and rather than copying some boring one from the internet, we can just take a funny one and then see if our model is able to work with it. Um, Let it complete file. Let's create text file. Okay, done. Let's copy. Okay, that's my data, and now we need to implement our database. So the I checked a few ways of doing this. Uh, the easiest way seems to be like just throw a configuration annotation on a class, and then you basically build the whole thing up. Um, all right, so I went ahead and pasted the code that we need here. Let me walk through that before we try to run it. So a few things are happening here. First of all, we are getting the data that we just created, which is our FAQ file. Then we need a embedding model. This embedding model will help in creating chunks of this data and storing it into the vector database. For the vector database itself, I am storing it on a JSON file. So why I'm doing this is that if we rerun the application many times with the same FAQ data, it doesn't have to chunk it and break it, and we'll see how that JSON looks once we run it. But like we won't have to run it. We won't have to wait for the database to get created every time. So that's what I'm doing here. If it exists, well and good, let it be. Just load the vector store with it. If it doesn't, if it doesn't exist, then use the text reader to read the FAQ, tokenize it, and basically just add it to the vector store and save it. So if you read more about vector stores, embedding models, and all that stuff, there's just basically lots of math behind the scenes, which helps the model in fetching data quickly. So right now, what we can do is let's give it a all right. So let's just run it. Obviously, we're not talking to the model yet, but what we'll see is see if the database is able to be created. So if we look at the logging, what it does is that it finds the document, then the text splitter is splitting it into two chunks. So based on how big the document is, it'll try to divide it in smaller chunks and then store it in the database. So then it calls the embedding model two documents, which basically the two chunks that it created. I mean, this is all what Spring explains very well here. So documents, then chunks, and then so on. So that's what it's doing, and then it creates the JSON file. So if we look at the JSON, we won't be able to make a lot of sense of it, but it has like different embeddings, and that's what it's trying to do. Okay. So now that we have our vector database, which supposedly has whatever we need, the next thing that we want to do is actually use uh, the model and chat with it, right? So for that, we would need a chat client. So let's go ahead and construct it. Have to use the builder, then do builder.build. This will give me the chat client, but what I'm interested in doing is using my vector store and giving that context to the chat client right here, because as I said, we want to give it the context it needs before we start talking to it. So let's also inject the vector store. It should pick this one. It should pick this simple vector store up here from this bean, and what we'll do now is we'll do builder dot default advisors question answer advisor, and then just pass this on. So if we look at what this is, this this just creates a context for question is retrieved from a vector store and added to the prompts the text. So rather than we passing the we passing all the context that we need every time, which might be like too hard, or it might like kill the context window and so on. So there are like other functions which are available to us to on the vector store to not pass the whole vector store. So like you can do like a similarity search and pass something here, which will then reduce the size of the stuff that you're passing to to the the model. But for us, I think the FAQ is not that big, so we'll try to just do it through this. All right. So what now we have left to do is just add a request parameter and work towards calling it from the chat client. So let's give it a value of question, and then we'll throw in a default value which can be something relevant to our FAQ, like where are the 2048 Olympics being held. All right. So that should be good. Now the only thing left to do is to actually integrate the chat client. So the way to do that is pass in the question which you're coming in, uh, and then call the prompt. So what we are doing right now is the prompt is there's no prompt coming. The question is coming from the user. We're calling it, and then we're serving the content. So now if we rerun the application, the one thing to note is that it doesn't create the database again. It just directly starts the application because the database already exists. Now let's go ahead and fire the default route. So the default route should take the default question, which is where the 2048 Olympics are being held. Now let's see what the model replies. All right, so it tries to be funny. What it tells us is that uh, it detects that it's a hypothetical scenario or a work of fiction. There's no official announcement of a 2048 Olympics being held on Mars, so it's just trying to be very precise and thorough with it. Now let's ask a few more other questions, like the one that I had that I have above. So, what are some exclusive games mentioned? Uh, let's see what does it answer to this one. All right, so it says there are no exclusives mentioned, but it does mention some of the games which are there. So it talks about traditional track and field, and then it talks about some game sports which are adapted to the Martian environment. Let's do another question just to like close it out, and then we'll like finish it out. Let's do the one with the water-based events. Let's see what it tells about that. So let's put in our query. We can say simply what about water-based events, and let's see what the LLM has for us this time. And yeah, so it gives an answer that there will be water events by transporting and purifying water in specialized centers, and there will be things to replicate the Earth's pressure. So yeah, this kind of shows you what is possible through the RAG architecture. Just to revise, if you wanted to just chat with a local LLM, if you have Ollama installed, you only need the first property, and it should be able to talk to your model which is running locally. So now I'm trying to show you what was this Spring application talking to. So it's talking to this model which is running on Ollama. So Ollama PS gives you all the running ones, and then because we had the RAG architecture, we did the embedding model as well. In terms of dependencies, nothing special. We did Spring Web, and then we did a Ollama Spring Starter. That gave us everything that we need. We created a fake FAQ document using ChatGPT. Then we converted it into a vector database, which is here in this JSON file, so that we didn't have to talk to any other services. And then finally, we had the controller where we use the default advisor to set up a question answer advisor using the vector store, which we just saw. And then we had the endpoint where we were conversing with the client. So yeah, I feel like some use cases here could be like you have documents locally which you don't want to send out for security reasons outside your company or privacy reasons, whatever, and you want to run something locally, like build a chatbot which can understand all these documents and then answer and converse with you with that context. So I think running it locally with that sense makes a lot of sense. And the Spring AI project is moving at a very good speed. So if you're a Java developer and you want to like fiddle around with LLMs and everything else, I think Spring AI is the way to go. All right. Until next time. Bye.